So in 5.B.1, we jump into the type of thing we'll be dealing with here, technically for the rest of the semester. We define this word polynomial eventually, and that's going to be a word you'll hear over and over again in Chapter 5 and Chapter 6. It says here some review of terminology. The word term, we've talked about the word term, is a combination of a number part and a variable part through multiplication. We'll get more into that as we see some examples, but just a reminder, we've defined that. We've defined a coefficient as the number part of a term. And when we talked about like terms back in Chapter 2, we really focused on terms having the same variable, but I took the time to point out that it also was a requirement that those variables have the same exponents if they're going to be like terms. I knew that'd be important coming up in Chapter 5. So, a couple definitions that are new to us. This word polynomial says that the collection of one or more terms combined through addition and subtraction. This is kind of an oversimplification of this definition, but for our purposes, this is going to do. So combining one or more terms. I'm going to jump down to the example just to point out an example of a polynomial. This would be an example, a collection of terms. X is its own term, then 12x cubed, since they're combined through multiplication, is its own term. This minus sign does separate, but also it's included as part of the term negative 3x to the fourth, negative x squared, and negative 5. Each of those is a separate term. So let's start with that actually, and let's fill in this chart right here and just identify those terms I just listed. So first term of x, next term of 12x cubed, then minus 3x to the fourth, or negative 3x to the fourth, negative x squared, and negative 5. So there's our 5 terms in that polynomial. Now back up here to the next term here. The term is the degree of a term. The degree of a term is the exponent on the variable. Simple enough. You look at your exponent part of your term and you decide what, or your variable part of your term, and you look at the exponent. So this term has x. We don't see an exponent, which means we've said that means it's a 1. So the degree of this coefficient, or this term, is a 1. The degree of the next term, x cubed, 12x cubed, it's the exponent of 3. Next term exponent is 4. Next term exponent is 2. Now the last one, when you do not see a variable at all, right, there's no x in here. Remember, we call this a constant. This is going to have a degree of 0, right? There is no variable, none, 0. Also, that's mentioned right here. The degree of any constant will be 0. That's what we've got there. So let's go ahead and let's fill in this middle column as well now. The coefficient, remember the coefficient is the number part of the term. So when you don't see a number out front, right, we don't have a value, we've also said that's an implied 1. So real quickly, just to point this out, that's the difference. That one is the coefficient. The implied 1 that we didn't see there was of the exponent is the degree. Other than that, the number parts of these terms, that term's 12. This term is the negative 3, again, focusing on the negative sign being a part of it. This term, again, we don't see a number, so it's negative 1. And this term is only a number, so negative 5. So there's our chart filled in. Now we have one more term up here. The term or the phrase is the degree of the polynomial. So same word degree, the difference is whether we're talking the degree of a single term or the degree of an entire polynomial. And notice it's just the largest degree of any term in the polynomial. So if these are the degrees that we just found of our terms, the largest one in this case would be the degree of the entire polynomial, which would be 4. And then a couple other terms will be thrown around here. As we look at a lot of polynomials, we like to classify them based on their size. And so the 3 most common sizes of polynomials we'll see are polynomials with 1 term, 2 terms, and 3 terms. Now the key here is these terms here, these phrases, are really meant to describe a polynomial once you have all like terms combined. So you're not going to see any like terms in these. Now for a monomial, it's only 1 term anyway. But just as a reminder of what things could be a term. It could be a number, it could be a variable, it could be a number and a variable, it could be a number and a variable and an exponent, it could be anything. It could be negative 1/3 x to the 5th y to the 2nd z. It's stuff combined through multiplication, right? There's no addition or subtraction separating things in there. That's 1 term, right? Read it left to right, you see all multiplication. That's a single term, so we call that a monomial. Mono for one, or single. Binomial, bi telling us two. But again, not like terms. So you might have something, like two separate variables, like x plus y, right? Those are not like terms. Or you might have a constant in a variable term, like 2 plus 3x, right? Those are not like terms. But going back to that idea of the same variable and exponent for things to be like terms, like we discussed a bit in chapter 2, we learned that if I had, say, 2x squared plus 3x, even though those both have an x in them, we would call one an x term and one an x squared term. So even those two terms are not like terms. They have to have the exact same variable and exponent on that variable to be like terms. So those are some examples of binomials. And then of trinomials, again, same thing. They got to all be different. So maybe x plus y plus z, right? 3 different terms. But the most common trinomial we will see, and we'll talk a lot more about this in this chapter and the next, would be something like this. Maybe x squared minus 5x minus 6. And we will see this pattern over and over again. This is a specific kind of trinomial where you've got an x squared term, an x term, and a constant. Quite often I call this the x squared x no x trinomial. It's just the way to describe the pattern. But we see this so often in this class and in future algebra classes, and there's lots of special things about it that we're going to learn. So I just like pointing out that this is a trinomial we will see over and over again.